Hello everyone, I'm Wei. I will go over the home exercise today with you, and I hope you're doing well and you enjoy deep learning course. Okay, let's go to the question. The first is about what's the difference between feature-based representation and fine-tuning these representations. Okay, the first thing is feature-based representation is the original embeddings that we can obtain from pre-trained BERT models, but we cannot use these representations directly to some downstream task without any fine-tunings um, because they don't have any task-specific knowledge, right? For example, if we want to classify, we want to use these embeddings for task classification task. We need train a model, train a system, train a classification systems on the task classification dataset, right? Uh, so as this is also the things for BERT. So if we want to make the BERT to classify test, and we need fine-tuned feature-based representations on some test classification corpora to get such capabilities for BERT. Okay, the second question is about the improvement of BERT over GBT. GBT is a generative models, and the goal of the GBT is to predict nested tokens given previous ones. So GBT cannot use bidirectional contest. This is in contrast to BERT, because BERT is trained with masked language model. So, for example, we can mask a specific tokens of input sequences, and we use bidirectional context informations and to predict these masked tokens, right? Okay, the next question is about the principles of both for training objectives using BERT. Um, yeah, BERT has been trained on a very large corpus with two pre-training objective functions. The first is masked language models. Another is the next sentence predictions. Yeah, I think this solution is pretty clear here. So yeah, I will just skip this questions. Let's see the question number 4. On which families of tasks can BERT be applied? Explain the structure of the input and output of the model for each task. Honestly, I don't know what tasks BERT cannot be applied because it's quite famous. It already, I know the BERT has been applied in everywhere, every task, every language now. Um, okay, so the first thing is for all the tasks, we need to insert two special tasks, CRS and SEP, into the input sequences. Then, uh, then we feed these modified input sequences into a specific task. Uh, First task is sentence pair classification. Then we use the input. Then we use the concatenated input, uh, which are separated by special tokens. Then we feed uh, this input into a transformers, and then we can get the CLS. Then we can get the embeddings for the CLS tokens, and which is able to present the whole sentences. So usually we use the first token, we call it the CRS tokens, as the sentence embeddings to present the whole sentence. Then we feed that sentence embeddings into the linear classifiers, and which can output uh, they can do some label predictions. Okay, the second is a single single sentence classifications. This is almost the same as sentence pair classifications. Okay, then the next task is band predictions. Uh, the the input is also quite similar with the previous ones, but the output is very different because the QA task is suppose we have a document and one need to identify the exactly where the answer is, right? So we need to so specifically we need to know the position of the answer in the paragraph. So the BERT models. If we fine tune the BERT models on some QA task, then the models will be able to predict the start and the end index of the answers. The last task is the tagging task. The one thing is uh, you might already notice that um, um, is BERT can handle with the auto vocabulary issues, right? And using word piece tokenizers. But as a byproduct, these tokenizers will split every word to subtokens, to several subtokens. But how, but the label of every tag, but the label of tag is assigned to the whole word instead of the specific subtokens, right? So something we need to do is before we link the embeddings, the subtoken embeddings to a specific tag, we need to do average. Um, we need average embeddings we need to average embeddings to get the word embeddings, right? Then we can link these word embeddings into the original tag and to learn some linear transformations to make the model work out. Okay. Okay, let's have a look at the second question, dependency parsing. Sometimes there have some ambiguity in the sentence, as discussed in the lecture, and in this case, we will see some ambiguities in the conjugations. Okay, so you can see here the sentence. Given the sentence, I ate the nice fish with a spoon. There's two solutions, and one can link fish to with, or we also can link ate to with. Okay, so yeah, for these figures, and you can join it with some spicy, which is a very useful tool and can generate many linguistic features like dependency parsers and post taggings and also many others. Okay, yeah, that's all for this home exercise. Okay, see you next week. Okay, let's have a look at the exercise solutions. We will go through the bingo questions first, and the first question is about recurrent neural networks. And the first statement is not correct because every iteration has their own weight matrix instead of different ones. And the second is about information about the second is correct because because a recurrent neural models is basically a single uh, modules which is enrolled in times. Um, then other previous inputs can be somehow memorized and feeding into uh, the models. to process. The last point is we can process input sequences of arbitrary lengths, which is also correct uh, because we have the padding. We can use padding techniques to reshape the variable length of input sequences into the one with same length. Okay, the next question is about CBOM. Why CBOM are not being applicable on full sentences? This is because the last statement is not correct because if we treat a sentence as a very long word, and it will have very high abilities, and that we face out of vocabulary issues, right? Okay. Move to the next part and the sentence embeddings. List the two reasons why the naive approach of creating a sentence embeddings by averaging word embeddings might be not good idea, because the first reason is averaging does not take a word order into account, right? This is very clear. The second is the stop words needs special treatment, because if we don't do any special treatment, the averaging the mass averaging operations will assume all the words have the same importance to the semantics of the sentence, right? But this is not correct, because there are many articles, pronouns, interjections, which do not contribute a lot to the meaning of the sentence, right? So sometimes we will downplay the weights of them. Okay. Then the next question is about the list of 4 sentence representation techniques covered in the lecture and explain them. In generals, and we can get sentence embedding either from sentence encoders or word embedding conversions. But as we discussed, and the conversion word order the word embedding conversions is quite tricky, because averaging operation is not reliable solutions. So some people propose different ones, which called concatenated power mean embeddings, which use some statistics informations to make the embedding, to make the sentence embeddings, to make the word embedding conversion more meaningful. Okay, yeah, I think that's it for the exercise today. Okay, bye.